this section we're gonna explain about the kinematics equation. This is what we already known in our high school class for when we determine the motion and behavior of the motion. So this is the four main equation that we're gonna use from this step to other part of the calculation, not only in one dimension, also in 2 and 3 dimension. You can apply the four main equation for explain the kinetics, which is we call the kinematics equation. So it start with the instantaneous acceleration. So you know it's from differentiation of v over dt, right? Or dv by dt is the acceleration. How can you change this to the initial velocity and the terminal velocity relation? So we will see. So from this part, you can rearrange the term is a dt equal to dv, right? Now, rather than you do differentiation, if you would like to get the term of v, you use the integral into it and take a limit of integral to maybe from the initial point to the final point, and to the initial time maybe 0 to the t time point. You rearrange this term to like got dv equal to a dt and integral v0 to v and from t0 to t. So what you get from this one, you got v out of it, and you take limit v0 to v equal to a t. The limit is 0 to t. To take a limit, you sub all in. So now you got v minus v0 equal to at. This is how you rewrite it, like v equal to v0 plus at. So is this the usual relation that you mostly use for investigate the motion of the object when the object have the initial velocity and change to another terminal velocity? So the change is due to the acceleration or deceleration with the specific time. So you can see with this equation you can find and determine or predict what is happening of the particle motion. So how about the another equation? We call this equation 1 of the four main equation. So how about the another one? So you have the relation of the displacement, the terminal and initial velocity and time. So let's start from the information of the v average. So we know the v average is from the displacement over the time, or the x minus x zeros over the time, right? This is your displacement. So to determine this, you also know the information of v average. If you would like to average something, you have the initial v, you have the terminal v, and you divide by 2, you average them. So substitute this to this v average. So now you're gonna get x minus x0 equal to v0 plus v over 2 and multiply by t. So this is the final term, x equal to x0 plus 1 over 2 v0 plus vt. So this term you may also known as s equal to v plus u over 2t. So the way to select the familiarities of the equation you ever use is depend on your choice. You can use v0 to represent the initial velocity, or use u instead. It depends. So this equation you may get used to in terms of v equal to u plus at. So it depends. You can use this one or this one. So you can choose it. right? Which is this s or displacement is x minus x zeros, because the final position compared to the initial position is the displacement. How about the third one? This is the third one. You have the relation of the displacement, the initial velocity, and acceleration. So let's start from the equation 1 of the kinematics four-main equation. So this is your first equation. You got v equal to v0 plus at, and you also know that the instantaneous velocity is the diff of the position or displacement over the time. So with this relation, you sub this into v. So you're gonna get the dx by dt equal to v0 plus at. And now what you're going to do, you rearrange it. So you have the dx equal to v0 dt plus at dt. Have the limit in it, x0 to x, from t0 to t, from 0 to t. So from this term you got x minus x0, because you x and you have the limit in. I will take limit and sub it in later. So x, and you have the limit of x0 to x equal to v0t, and limit from 0 to t, and plus a t squared over 2 from 0 to t. So now you get the final x minus x0 equal to v0t plus 1 over 2 at squared. This is your third from four-main equation. You may get used to the form of s equal to ut plus 1 over 2 at squared. You can use this one if you get used to it. But s is also known as x minus x zeros. These are all vector that you see. The x zeros, even v0, v, and a, we define this as a vector. Don't forget it. You have the direction and magnitude for these values. And how about the fourth equation? The fourth equation is related to the terminal velocity, the initial acceleration, and the displacement. So no time involved in this equation. So you start from solving it from the instantaneous acceleration and apply with the chain rules. So what is the chain rules? Chain rule is the way you change the term that you differentiate to compare with, because the influence of this terminal velocity is depend on displacement only. So in no state of the times in this point. So to apply the chain rules, you use dv by dt, and you multiply by 1, and this one can be anything. So for chain rules, use this benefit to sub the x by the x as a 1 into this term, and you change the position. So this can be dv by d, switch this x to this, you sub x to dt and dt back to dx, so you got dx dt. What happened to this? You have dx by dt here is instantaneous velocity. So now you got this form instead. You got a equal to dv by dx and v. So now you change this term. You have the x over here, and now you got v dv from the left one on the right. This is your right hand that has been left after you have dx over here, equal to a dx, and put the integral term into it. What you want from is maybe from v0 to v, from x0 to x. So the final term over here is v squared, that you put the limit to it, So you got v square over 2 from v0 to v equal to ax from x0 to x. So now you got this term as the v square minus v0 square, and you got this 1 over 2 and change to this side, it's got 2ax minus x0. So this is your fourth equation. You may also get you to this form, like v square equal to u square plus 2as, and s is your x minus x0. So these are four main equations that you will use it to explain the kinematics or the motion of the objects. So I will sum up four main equations here. And when you use it, right? So you will use this relation when you have all the information of the v as a terminal velocity, initial velocity, acceleration, and time. You have, maybe you have three information of this, and you want to find out what another one. So you can use this equation. This equation not suitable for the thing that involved with the displacement. If this equation asks you about the initial displacement or position or the final position, just ignore this equation. And how about this equation? It's mainly related to the displacement, right? The terminal velocity and the initial velocity with time. So rather having this information, not using this equation. For example, like if it's stated about acceleration or asking about acceleration, please not using this equation for solving it. How about this one? This one having the displacement again, have the initial velocity, have acceleration, and also the time. So if all these information involved, please use this equation. But if it's involved with the terminal velocity, don't use it. Right? You can see some limitation. The red line is like limitation for the individual equation in our four main equation, or four main kinematics equation to be precise. Right. For the final one, you should have the information of v0, a, and displacement or position. But you don't have the information of time. If you have thing that involve to this equation relation, please use this equation. But if you don't have anything about the time or asking about the time, please don't use this equation. However, these four main equation is linked together, so you can use both of equation to solve one problem. Or if that specific information have all these parameters involved, you can select just only one equation to use. You can use all four or use only one. It depends on situation or the problem that you observe or try to predict or explain it. So let's see about the first problem. So this is about the aircraft and a plane landing on this aircraft carriers. As you can see, the plane start touchdown for landing, not the car, a plane, right? And then stop at this point. This is like stopping point. This is like a touching point. So when planes start touching, it have this initial velocity as 140 miles per hour. But when you convert this mile per hour, it's about this v0 is about 63 meters per second. After touching, it's moving away to the end of the carrier, and it spent 2 seconds. And when it stops, this means the terminal velocity is equal to 0. The question is asking about the first one is the deceleration. I will move this one. This is the first question. What about the deceleration? And about the second one, the distance that is moving. So it's asking about first one about the deceleration. How about it? And the second one about the distance or displacement. As you can see, the distance and displacement are interplay around this 1D motion. But to make you know 1D motion that is happening here, the precise definition is displacement. But sometimes, because it's happening in one dimension and moving only one direction, we can also this as the distance. But what we state all the time, most of the physical quantities here we explain about the vectors. Okay, let's start with the deceleration first. If you would like to find or determine the deceleration, how to find it? Think about four main equations. Any equation related to the terminal velocity, initial velocity, and time, and would like to know about the acceleration? Yes, the first one, right? V equal to V0 plus AT. So by this, if you would like to determine the A here, you can rearrange the term, change this to V plus V0, and you got T to divide it. So you got A after this. So you can sub all the value in and rearrange later or rearrange first. So for the sake of easier calculation, I will do like this, and this is what you can find your A. And V initial is 63. But you sub in later. What V0? V final first is 0 minus 63, and divide by T is 2 seconds. So now you get the acceleration for minus 63. Minus 63 over 2, which is minus 31.5 meter per second square. So when you define and you see the minus sign like this, it means rather than you moving forward, the direction is backward direction with this magnitude 31.5. This is the first answer for the first question. So how about the displacement that asking you in the second question? Think about the four main equation again. Now you already know the parameters of most all of them now, right? Like instead of initial position, which is like zeros. So you would like to find the total displacement. The displacement is x minus x zeros. So you have like most of the equation related to this, but if you pick one, try to use the final equation, the equation 4. I will write down like this. This is your first equation in four main kinematics equation. So this is the equation 4. What is it? Is this V square equal to V0 square plus 2AS? And what would you like to find? You would like to find this as. And now I will sub in first and rearrange for you. So now you can sub everything in. We final is 0. 0 equal to initial velocity is 63 square. And how about the acceleration? We already find it. It's minus 31.5 and S. So now you can find S is equal to the minus 63 square and divide by 2 multiplied by 31.5. So now your displacement is 63 meter. Now you can see the plus sign. So the displacement is in forward direction, and unit is meter, right? I will remove this part first because we're not gonna use this. So now what you can see, you can use four main equations to explain the behavior of the airplane or aircraft landing on the aircraft carrier. So that remind you of the importance of four main equations. Here you got the relation of V and V0 plus AT for the first one. You got S equal to V0 plus V over 2 and multiply by T for the second one. Another one is S equal to V0T plus 1 over 2 AT square. This is your number 3. And your number 4 is V square equal to V0 square plus 2AS. This is your number 4. So these four main equation is quite important for explain about the displacement, velocity, acceleration, and time of the motion of the object, with not only in one dimension, also in 2 and 3 dimension as well. So the next part is free falling. This is also a one dimension moving as well, but free falling mainly due to the gravitational acceleration. This is your A, but on the Y direction. So you can have this value as 9.8 or 10 in J direction. But if you state this is the plus Y, this is the minus J direction. This is the example of the experiment. Without the vacuum or some resistance from air, two of these mass, the feature and the bowling ball, they're not going to drop at the same rate because some resistance of the air. But when you remove all these resistance out of it, what is happening? This is the experiment from BBC 2 that this Professor Bangkok tried to do the experiment for you. So when you remove all the air and the resistance of the system, what is happening? Only the influence of this dropping is only purely to the G. As you consider from four main equations, there nothing related to the mass. So that means if you drop with the same rate, these two objects gonna go down with the same time until it reach the floor at the same rate for M1 and M2. This is the real experiment. You can see the feature drop down, the bowling ball drop down at the same rate, and only influence is due to the acceleration, which is the A. Here AY is equal to G. This is how it happened. It dropped to the floor perfectly with the constant acceleration as 9.8. Here as you see, it's dropped with different rate because it's some air resistance. That is why this is the importance of the gravitational acceleration and the free falling object. Okay, let we observe through the example and we examine what is happening. When we try throwing the ball in one dimension, you can define like the upward is plus sign and downward is the minus sign. So now it's happened only in one dimension, only in y-axis, and the influence of the acceleration mainly due to the G here in downward direction. So this is going to be in the plus sign. If this guy throwing the object upward and this ball or this stone moving from A to B to C to D to E, what is happening here? We can use our four main equation to explain it. So four main equation, four main kinematics equation to explain it. That is quite important. And see how to determine it. So now we would like to determine the time that the stone traveling from A to B. So from this point B is your your highest position. What it means in terms of the highest position? That means object will keep moving. When it reaches the highest, that means there's no further velocity upward. The velocity at the P point going to be 0. This is the terminal velocity and the definition of the highest position. So if you would like to determine the time here, you know the initial velocity, right, which is tell you here about 20 meters per second. You can determine the time using the first from four-main equation. I will write down four-main equation again, like v equal to v0 plus at. The second one is s equal to v plus v0 over 2 multiplied by t. And the third one is s equal to v0t plus 1 over 2 at square. And the fourth one is v square plus v0 square plus 2as. So now this is your four main equation. So if you like to determine the times, or which equation you would like to choose on it. So you don't have any displacement, right? Don't have any displacement. So only choice that you have is the first equation, v equal to v0 plus at. So let's sub all the information that you know in. The point B, the terminal velocity is 0. So you got 0 over here equal to v0, which is upward. So don't forget the sign here as well. It's quite important. So plus 20 is going upward because it's throwing upward here. Plus sign. And how about the acceleration? Acceleration only happen here is g, right? So you got downward g and multiply by t here. You already known. So let's state that I'm gonna use g equal to 9.8 here. So let's assume g equal to this. And what you're gonna find about the v here, I will sub t and show you here. So t gonna move to another side, and you're gonna get 20 divided by 9.8 because this is 9.8. I will sub in. Alright, and this is your g. Change to another side, minus change to the plus sign. So the time is in the plus only, right? Time don't have direction. Time is scalar quantities. You don't move backward from the time. If time is minus, you move backward. In this case of the classical mechanics, you're not allowed to move in backward. So now, what you're gonna get, you get the time equal to 2.04 seconds. This is the time that stone moving from A to point B. If you would like to determine the distance or displacement from point B to A, or how about the how far or this distance here, you can use other relation to determine it, because now you know the time already, right? You can select equation number 2 or number 3. You can use it. It depends on each other, but I prefer to use number 2 because you can do calculation more easily. Or if you like to use number 4, it's also easy as well. I will show 2 methods and you can determine whether which one is easier. So if the second one is v plus v0 over 2 equal to t, and this one is v square plus not plus, I'm sorry for this mistake, equal to v0 square plus 2as. So you sub everything in as equal to v terminal is 0 plus v initial is plus 20, right? Divide by 2, and time you know is 2.04. And how about this one? you know, terminal velocity is 0, equal to initial is 20 square. Add the signs in just in case, and you plus with 2 that multiply with minus 9.8, and S is what you want to find. So your S is 400 over 2 that multiplied by 9.8. The height of this position is 20.4 meter. Exactly the same. Right, let do the calculation and check on it. Because this you divide by 2 to the 10 and multiply with this term, you get this one, or you multiply from this term and calculate. So which one is easier is your choice. You can see, you can not only use one equation, any equation that have all the information here, like S, V, T, V, AS, because you have all these information, you can use it for find the height or the distance between A and B. So the final one asking you to determine the velocity at this position. So now you have all the information, but you don't know about the time that this traveling. So the key information is, you know, the displacement here is high behind you, and state about this displacement is 50 meter. But what's the size of this displacement is in minus sign, because it's going downward here. The downward direction supposed to have the minus sign. So now you know the displacement, you know the initial velocity. You would like to find the terminal velocity, so you can use the fourth equation of our four main equation here. So that equation is v square equal to v0 square plus 2as. Now you can determine the terminal velocity here, which is sub all the information in. So v0 is plus, because it's moving upward, plus 20 square, and plus 2. Your acceleration A is minus 9.8, right? And the S is 50, which is downward direction. So don't forget to add as minus 50. I will remove this one for the sake of you knowing they have the same result over here. Okay, so this is minus 50. This is quite important. So you will see the importance of giving up the sign, not giving up, getting the right sign in front of the magnitude is due to the direction that you state. If it's upward from, this is your initial state plus, and if the point downward is going to be negative sign. For this case, this is quite important. Be careful about it.